Today, we will be discussing the different stages of sleep. Throughout the video, we will describe the differences between REM sleep and non-REM sleep. We will also describe the difference between the 4 stages of non-REM sleep. And however, we will also describe the role that REM and non-REM sleep play in learning and memory. Sleep is composed of several different stages that can be differentiated from one another by the patterns of brainwave activity that occur during each stage. These changes in brainwave activity can be visualized using EEG and are distinguished from one another by both the frequency and the amplitude of brainwaves. Sleep is divided into 2 different general phases, REM sleep and non-REM sleep. Rapid eye movement sleep is characterized by darting movements of the eyes under closed eyelids. The brainwaves during REM sleep appear very similar to brainwaves during wakefulness, but in contrast, non-REM sleep is subdivided into 4 stages distinguished from each other and from wakefulness by characteristic patterns of brainwaves. The first 4 stages of sleep are non-REM sleep, while the 5th and final stage of sleep is REM sleep. The first stage of non-REM sleep is known as stage 1 sleep. Stage 1 sleep is a transitional phase that occurs between wakefulness and sleep, the period during which we drift off to sleep. As we drift off to sleep during this time, there is a slowdown in both the rates of respiration and heartbeat. However, stage 1 sleep involves a marked decrease in both overall muscle tension and core body temperature as well. In terms of brainwave activity, stage 1 sleep is associated with both alpha and theta waves. The early portion of stage 1 sleep produces alpha waves, which are relatively low frequency, about 8 to 13 Hz, and also high amplitude patterns of electrical activity that become synchronized. The displayed graph represents the brain activity of someone who is very relaxed yet awake. As an individual continues through stage 1 sleep, there is an increase in theta wave activity. Theta waves are even lower frequencies, about 4 to 7 Hz, and they also have a higher amplitude brainwaves than alpha waves. It is relatively easy to wake someone from stage 1 sleep. In fact, people often report that they have not been asleep if they are awoken during stage 1 sleep. As the body moves into stage 2 sleep, the body goes into a state of deep relaxation. Theta waves still dominate the activity of the brain, but they are interrupted by brief bursts of activity known as sleep spindles. For those who don't know, a sleep spindle is a rapid burst of higher frequency brainwaves that may be important for learning and memory. Also, the appearance of K complexes is often associated with stage 2 sleep. A K complex is a very high amplitude pattern of brain activity that may, in some cases, occur in response to environmental stimuli. However, K complexes might also serve as a bridge to higher levels of arousal in response to what is going on in our environments. Therefore, we could state that stage 2 sleep is characterized by the appearance of both sleep spindles and K complexes.
Stage 3 and Stage 4 of sleep are often referred to as deep sleep or slow wave sleep. Because these stages are characterized by low frequency, up to 4 Hz, high amplitude delta waves. When in these stages, an individual's heart rate and respiration can slow dramatically. Also, it is much more difficult to awaken someone from sleep during stage 3 and stage 4 than during the earlier stages. The figures shown above, A and B, include delta waves, which are low frequency and high amplitude, characterize slow wave stage 3 and stage 4 sleep. REM sleep is marked by rapid movements of the eyes. The brainwaves associated with this stage of sleep are very similar to those observed when a person is awake. This is also the stage where dreaming occurs. It is also associated with paralysis of muscle systems in the body, with the exception of those that make circulation and respiration possible. Therefore, no movement of voluntary muscles occur during REM sleep in a normal individual. REM sleep is often referred to as a paradoxical sleep. Because of this combination of high brain activity and lack of muscle tone, like non-REM sleep, REM has been implicated in various aspects of learning and memory. Although there is a disagreement with the scientific community about how important both non-REM and REM sleep are for normal learning and memory, if an individual deprived of REM sleep is allowed to sleep without disturbance, they will spend more time in REM sleep to regain back the time they lost in REM. This is known as REM rebound. REM sleep is also known to be related to memory and learning. However, REM sleep is also involved in emotional processing. While sleep deprivation in general is associated with a number of negative consequences, the consequences of REM deprivation appear to be less profound. In fact, some have suggested that REM deprivation can also be beneficial in some circumstances. For example, REM sleep deprivation has been demonstrated to improve symptoms of people suffering from major depression.